Let us now look at one of the applications of pointers, and this is a number swapping example. So this is the classic example of call by reference, and when we say reference, this actually means call by reference address. So this is a function call by reference address. Now we will proceed on similar lines with respect to the last example of call by value, and so we have a steady io.h int main, and we have two integers int x which is equal to 50 and int y which is equal to 100. And before calling the function which will swap the values of x and y, we will print this value. Let us say printf x equal to percentage %d comma y equal to percentage %d comma x comma y. So this is the value before function call printf before function call. And now we make a call to this function. So let's name the function as func underscore reference, and instead of passing the values of the variables x and y as we did in the call by value method, now we will pass the values of the addresses of x and the address of y. So ampersand x is the address of x and ampersand y is the address of the variable y. So let's go to the function func underscore reference and try to build this function. This is func underscore reference. Now since the addresses are passed from the main function, func underscore reference would capture them in pointer type variable. So we have integer pointer. Let me name this as ptr underscore x, and let me name the other pointer type variable that captures the address of y as integer pointer ptr underscore y. And what we can do is we can write pointer ptr, that means the value at address of x. Let me make this 100, and the value at address of y is 50. So this is exactly the opposite of the numbers which were sent to it, which was made in the main program. So x had a value of 50, y had a value of 100, whereas with these pointer type variables, the value at the address of x is now made equal to 100 and the value at the address of y is made equal to 50. And the function is not going to return anything, so let me write the return type as void. Copy this, and this becomes our function prototype. And now what we want to do is, after making a call to this function func underscore reference, we would again like to know what is the value of these variables x and y. Will they remain the same like 50 and 100 as it was in the case of call by value, or will these changes be reflected as the swapped values after making the function call? So printf new line character, after function call, what happens to these values? So x equal to percentage %d, y equal to percentage %d, x comma y. So let us go ahead and try and run this code and see what is the output. Okay, so before function call x equal to 50 and y equal to 100. This is exactly what is expected from these four lines of code. And then the function call was made here. This is a call to a function whose name is func underscore reference, where we are passing, instead of the values of x and y, we are passing the addresses of x and y. And in this function the values are changed at those locations only. So the value in the memory location for x, which was equal to 50, is now overwritten and it is 100. Similarly, the value in the memory location allocated to y, that is now also overwritten and it becomes 50. So this is a direct change in the memory location. Instead of providing copies of the variables x and y in the supporting function as it was for the call by value method. So to sum up, this change is taking place directly in the memory location allocated to variables x and y in the main program. And therefore, what we find is that after returning back to the function, so after the function call, x and y, these values are simply swapped, because this is the part of the program that has done that swapping. So this is a permanent change in the memory location, and this method is called as call by reference method.